Hello, hello. Morning. Okay, let me see. Where are we? Good that you're here. We will wait a minute or two till everyone is here. We have a relatively small group today, purposefully, because we're going to do some difficult topics. So then there's more space for questions. Just to start off with, can you all hear me properly? Can you say yes in the chat if you can hear me? Just to make sure that's okay. Because it's quite a crucial aspect of teaching, I've noticed, like being able that you can hear me, like the audio aspect seems to be rather important. Okay, I see yes in the chat. Okay, wait a few more seconds and then we will get started. Okay, like I said, relatively small group today, so we're just going to get started in a minute. Some people might still join. But we're going to do that because we're also going to calculate with main facts interactions. And that is quite an interactive part, so we choose to create the groups as small as possible. Okay, welcome at this core training for methodology. This is the exam analysis. By the way, you will get the slides, so you're allowed to make notes. But just so you know, this is approximately how much each lecture is represented in the exam. Having said that, if you have any questions in the meantime, you can just ask that in the chat. That's perfectly fine. Also, we're going to have a break halfway through, so you can ask your questions there. That's all perfectly fine. Well, most of you I know either from the full training methodology, I recognize your names, or from experimental psychology. But just as a quick introduction, I'm Patrick. I also studied psychology also at Tilburg University. Also did the English track, so the international track. Had a good mark, good grade, and I'm going to help you today. That's basically the plan. And like I said, if you have any questions, ask them in the chat, ask them in the break, and also all the way at the end. You can also just text me after class. That's perfectly fine. What we're going to do today is I'm going to explain you some theory. So I picked from a lot of lectures, just the most difficult and most important exam topics. I chose them quite accurately based on how often do they come in the exam and how often do people make mistakes in those things. So I'm going to explain you the theory. I'm going to give you examples and, as you well know, also exam questions. This is the group chat for the core training, so I will give you a second to join that. You can also just text me privately, but if you ask your questions in here, then other people also see it. Other people might be able to help you as well. So I would recommend to join that. Probably you already have a surplus of group chats, but if you want to join this, you can. So I'll give you a second to do that. And for all means, let's get started. Out of curiosity, and you can say in the chat yes or no, do you feel you would be able to answer these three questions? So based on the graph, are there main effects and is there an interaction? Can you say yes or no in the chat? You can just be honest, because based on that, I know what pace to handle this kind of theory. Would you be able to answer these questions? You don't have to calculate right now, but just based on your knowledge, would you be able to tell me if there's a main effect or an interaction? Yes or no? Would you be able to tell me that? You can use the public chat or the private chat. I see some yeses in the private chat, some no's. Okay. We're not going to discuss this yet, obviously, but we are going to be discussing this today. Not sure, no, okay. Well, that's good for me to know. So indeed, give me as much input as possible. By the way, if at any point my connection struggles or something like that, my internet connection, just let me know in the group chat, please, because I'm not home right now. I'm abroad. Internet should be good, but you never know, so just let me know. Okay? Okay, this is one of the things we're going to be discussing today. And also, we're going to be looking at an exam question like this. So based on a table, you also have to be able to tell me, are the main effects, are there interactions? Would you be able to answer this? Can you say yes, no in the chat? That helps me determine the pace. Because if you all say yes, I will do it a little bit quicker. See some private chats. Okay. Well, see mostly no's. Well, that's somewhat of a good sign because that means that we're going to add value here today. So we're all going to be discussing this today. Like I said, we have 2.5 hours. So I particularly thought, how can I add the most value for you? So I picked some topics all over, and I'm also going to give you some, well, mental shortcuts, how to remember them the best way possible. We gonna start with independent and dependent variables. Obviously, you already heard this 1,000 times, but this is rather important for your entire bachelor. So even at a course as brain and behavior that you will get next period, it could be that they suddenly ask you a question with independent, dependent. So it's very important that once and for all, you remember it and you don't forget it. So how does that work? We have an independent variable. This is what we initiate. So what we first have. So we start with the I and then we go to the D. So I always said we initiate something and that means dependent. Therefore, thus, everything that's the conclusion that comes after is dependent variable. If you find it easy, you can also remember the abbreviation ID, as in, can I see your ID? We always start with the I and end with the D. One more way to remember it, dependent on what you like, you can remember that the dependent variable is dependent on the independent one. So this one, it depends. So let's say I tell you that, well, I noticed that when I've been smoking the entire evening, that the day after I have a hangover. Okay, so I say smoking causes a hangover. In other words, I say if I have a hangover, yes or no, that depends on smoking. So my hangover is dependent because that depends. Okay? Well, before I continue this, can I just see a yes or no or moi in the chat if this is clear? Because I'm gonna determine the pace on that. If I see a lot of yeses, I know I can continue. If I see a no, I will explain it again. If it's like a moi, well, then I know that probably I have to get back in a break. By the way, if you have a question, please use the big chat, like not the private chat, because I cannot open all the private chats. So if you just say yes, no, you can use the private chat. If you have a question particularly, please use the big group chat. I do see a question now in my private chat, so I'm going to answer that, but just for the future. Is the independent one always the one we manipulate? Very well, indeed. The independent one is the one that we manipulate. For example, it could be that some people I give a training, other people I don't give a training, and I want to see what does that do to your grade. So I ask you basically, does my grade depend on the training, yes or no? So this is my dependent variable, and my independent variable is training or no training, and that is indeed what I manipulate. Very well. This is what we manipulate, and this is what we measure. Independent, dependent. Well, probably you've heard of the concept of a confound. I think you've already heard that quite a few times. Today I'm also going to be discussing that, but also the difference between confound, obscuring factor, mediator, and moderator, because you have to be able to tell those differences. Before we get there, let's start with a confound. A confound is nothing else than an alternative explanation. So that would be, okay, it's fun and all that I see a connection between smoking and hangover. But that relationship between those two, that the smoking causes my hangover, that's not really true because there is a confound, an alternative explanation, which is drinking. If I've been drinking the night before, I tend to smoke more. And if I've been drinking, I get a hangover. So confound is a third variable that explains both. Can you say in the chat, maybe this is tough, but I want to see where you are. In the chat, can you say the question, if there are alternative explanations, yes or no, which validity does this talk about? Like what validity talks about the question, are there alternative explanations? Are there confound? Do you know that by any chance? You could just also guess. We have a few validities, obviously. Nice. See, the good question, indeed, internal validity. Internal validity, we're not going to be discussing the validities today, but you have to know very well for your exam, so I can already tell you that. You have to know very well all the validities and what kind of question is connected with that. And internal validity, just like Emily said, that is indeed connected with the question, okay, are there alternative explanations? If I look inside my test internally, is there maybe something else going on? For example, drinking that influences both. Well done. Okay. Well, I'm going to be discussing the type of confounds with you now, and later on in your course, you will also notice that these become very important. So later on in the course of methodology, you also have to be able, based on a research design, to tell particularly this might be a problem, this confound might be aware, this might not be aware, which is very important. For now, I'm just going to make sure that you know all the confounds by heart and that you're able to remember them. If you have questions in the meantime, like I said, just use the chat. Okay. Maturation. From the word to become mature. It's the best way to remember it. This means that because you get older, maybe you change. So a confound, like I said, is an alternative explanation for your effect, right? These are all alternative explanations for your effect. So what's an example of maturation? Let's say I give you a mathematics test, and now I tell you, okay, for 5 years in a row, every Saturday you have to meditate, and then after 5 years, I give you a math test again. And your score goes from a 4 to a 7. And then I say, hooray, meditation worked. Well, maturation would say, that's possible confounds, would say, well, is that because of meditating? Or is it just simply because of the fact that you grew older in 5 years and that made you better in mathematics? So maturation, if they are in an exam looking for maturation, they will give you an example and you have to pick out what kind of a confound could be a problem here. It's specifically about time making you better or worse. History is an overarching confound which basically talks about any kind of external influence. So almost anything else can be classified as history. So for example, I want to see how good the alphabet is. The alphabet knowledge, I have a few kids from like 8 years old, and I want to see how good is your alphabet testing. And let's say they score a 4. Now, okay, now let's say the next day, I show them Sesame Street, and I test them again, and they score a 10. And I say, hooray, showing them Sesame Street worked for the alphabet knowledge. Well, history would say, yeah, but it could also be that something externally happened in the meantime. So, for example, it could be that in the meantime, they went to school and they learned about the alphabet. So it has nothing to do with Sesame Street, but it's just an external influence, school. A little bit more of a cynical example. Let's say they score all a 4. I show them Sesame Street. Well, next day they have to do the test again, and they score a 1. And I say, okay, Sesame Street makes them suck at the alphabet. Well, if in the meantime the school burned down with all the children in it, and all my children are like burnt to crisps, and they're gonna score a 1. That's also history, just an external influence that I don't necessarily have control over. Before I continue to the rest, is the difference between those clear? Can I say yes, no, or moi in the chat? Nice. Okay. Indeed, and the more input you give, the easier for me to determine, because I've also have some extra topics all the way at the end. So if we are done earlier, I can discuss even more with you guys. So thanks for tagging along. Okay. Maturation history discussed. Regression to the mean. A lot of people find this one tricky, and it is rather important for your exam. What does that look like? Well, let's say we are talking about physical health. So sometimes you feel ill, and sometimes you feel better. And then you start feeling ill again, and then you feel better, and then you feel ill, and then you feel better, right? That's life. You get a fever every now and then, and you become better every now and then. Regression to the mean is also a confound, so an alternative explanation. So this would mean, and this is also what you see, if you are sick, you are more inclined to seek help the moment that you're sick, obviously. Otherwise, you don't go to a doctor. So let's say you're sick, you go to a doctor, and your doctor says, here you have a caffeine pill, something that doesn't really work for sickness. And use that every day, and in 3 weeks, you will feel better. And then indeed, in 3 weeks, oh, you might feel better. And you say, ta-da, my pill worked. Well, regression to the mean says the mean is your average. We're also going to see that later. Mean means average. Says basically, well, over time, you will always go back to your baseline of how you feel on average. So even if I don't give you any pill, if you're sick and I tell you do nothing and wait 3 weeks, you're generally going to feel better in 3 weeks because you're going to go back to your average. One example that I also like to give in your exam, so if you want to be able to recognize this well in your exam, is with depression. Very practical, applicable, right? Because you're a psychologist. And it's the same thing here. People that feel very depressed, they tend to seek help. They go for therapy. And then even if the therapy sucks, generally after a few weeks on average, they will feel better because life goes like this, regardless of the treatment. Is this clear for everybody? Can you see yes or no in the chat? Because some people find this tricky, so otherwise I'll explain it again. You can also just say another example, please. Those kind of things are all perfectly fine. Okay. And otherwise, if you don't feel comfortable speaking up, obviously that can also be the case, or if you don't want to stop me, just make a little note for yourself. Ask me in a break, ask me after class, and I will be happy to explain it again. Okay. Most important thing is that you get it well, because this is all important for your exam. Okay. A few more confounds. Attrition. Attrition is a specific dropout of subjects, of people. And this word specific is very important. Why? Well, if I do a study, let's say I have a new therapy form and I take all of you guys to try my therapy form. It's not a problem if two of you at some point don't show up anymore, because that can happen randomly, right? I can't force you to constantly do my treatment. So it could be that you just leave. That's not a problem. But it is a problem if it's specific. And I mean with that there is a specific kind of people not showing up anymore. And this is what you also see in psychology quite a bit, that if I do some therapy with you all, that my most depressed people here stop showing up at some point because they are depressed and they don't feel like going to therapy. And then I show all the, so let's say I do this study with 12 people, my two most depressed people don't show up anymore. And then I say, hey, look, I left with 10 people and they all feel great. So great therapy. No, because a specific kind of people, your most depressed people, dropped out. So if it's a specific kind of people, that's very problematic. And this is very important to understand for the entirety of methodology, because we're also going to see this with selection. And also, we're not going to be discussing that today, but the same goes for reliability. If things vary a little bit randomly, that's not a problem. That's life. But if it's a specific kind of variation, that is a problem, because then you're going to draw wrong conclusions. One that's probably a little bit easier to remember, testing. Familiarity with the test increases scores. So if I give you methodology exam, training, and methodology exam, and you score a 5, and you score an 8. Is this because of my training, or is this because you made the same test twice, and therefore you recognize the test, you become better at the test? We also call this practice effect, something we also going to be seeing later. So they're all very much connected. For methodology, it's also important to know that exam questions tend to differ and vary over the years quite a bit. So most people that followed the experimental course, they probably remember that there's quite some similarities between the questions I discussed and the one in the exam. So some of them are almost identical. With methodology, it's a little bit different, as in the topics stay the same that are important, but the way that they ask it changes every year quite a bit. So it's very important to understand the global concept. Okay, but I'm also going to show you some practice questions later because some questions do stay quite the same. Testing. Selection. I already told you, very important. Same goes for attrition. A structural difference, so not random, a structural or specific difference between my groups. What do I mean with this? Well, let's say new. Let's say I have a memory test. So that's the test that I'm going to conduct. And I tell people, okay, I want to see if people in the very early morning or in the late morning are better in memory. So I want to see the effect of early morning versus late morning. And I tell people, I ask people on the street to participate, and I ask them, okay, well, you can choose if you want to come at 6 o'clock in the morning or 11 o'clock in the morning. What's going to happen? 6 o'clock in the morning, if I ask a lot of people, all my very old people, like 80 years old, they all are going to come at 6 o'clock in the morning. Because, for some reason, old people always wake up at the dawn of time, they will wake up 4 o'clock in the morning or something like that. And you, young people, will come at 11 o'clock in the morning because you're not going to participate in something 6 o'clock in the morning. And what am I going to see? That these people obviously suck in memory because they're old. And you guys are going to thrive in memory. And I'm going to say, look, early morning makes you less good at memory. No, this is selection. There is a selective difference, a structural difference between the people in one group and the people in the other group. So if there's a difference between one group and the other group, then obviously I cannot tell if it has anything to do with my treatment, which is early morning or late morning, because the groups are inherently different. How do you guys think? You can say this in the chat. What would be a way to avoid selection? Do you have any thoughts on that? How can I make sure that my groups are not selectively different? If I have 10 old people, 10 young people, how can I make sure that those groups do not differ and that they're equally distributed? Exactly right. Random assignment. I don't let them choose. I just tell them, you're 6 o'clock in the morning, you're 11. You 6, you 11. Random assignment. The only other way how to fix this is matching. And matching is a method that I don't do it randomly, but if I have 10 old people and 10 young people, I specifically choose 5 old people in one group, 5 old people in the other group. So that I don't do it completely random, but I match the conditions. So then I choose, but I make sure that it's evenly distributed. Matching. Well done. Instrumentation. Also good to remember, because this is when the measuring instrument changes over time. So for example, I give you a happiness test. Well, and then let's say you score a 9 on that happiness test. Hooray, hooray. Then I give you caffeine, and then I give you this happiness test again. But let's say I see in this happiness test that there's one question that asks, how many carrots do you eat a day? Weird question, and I think, you know what? That question is actually not that good. Let's leave that question out for the second time that I ask you. And suddenly you score a 10. Is this because of my caffeine or because I changed my measuring instrument? If I change my questionnaire halfway through, obviously that's a confound, an alternative explanation for my effect. Lastly, very important one, the placebo effect. Believing that something works already makes it work a little bit. So even if I give you a nonsense pill that doesn't do anything, if I tell you you can run faster with this, you see that people generally are able to run faster. Little sidetrack, but I think it's very interesting in your psychology students as well, so I assume you find this interesting as well. I read a book about this, and this is such a strong phenomenon that you even see this with people that have multiple personality disorder, for example. They believe they have multiple personalities, and that belief, that placebo effect, is so strong that one personality can develop diabetes while the other doesn't. So the effect of what you believe on your physical state of your body is immense. And that's why placebo is a very strong confound that you always have to take care for. Obviously, you don't have to know that particular example. Probably you're going to be discussing it psychopathology later, but I find that very interesting. Are these clear for everybody? Can I see yes or no? Which is also somewhat good news, right? That the power of the mind is so strong because we are studying it. So if it would be sucking, then, what are we doing? All right, all right, all right. Okay. This is a very important aspect for your exam. You most often get more questions than one about this. And this is something you have to really, really grasp for all the statistical courses yet to come. So I'm going to walk you through significance testing step by step. And I really want to ask you to, because I'm going to ask you in between, do you get it? Yes or no? To really be honest with me, because I can do steps multiple times. But this is very important that you really grasp it. Because when I first had this course, I understood it for 70%. And that's simply not enough, because then you're gonna, if they ask you, and they might ask you difficult questions about this, well, you want to be able to answer properly. Significance testing, statistical validity. If we're talking about validities, statistical validity is about, is it statistically significant? What do? We always start with formulating a null hypothesis. And a null hypothesis means that you say that there is no effect or no correlation. So let's say I'm curious about the correlation between height and weight in the Netherlands. I'm interested in that. My null hypothesis is, okay, before you can, support anything, you have to assume that there is no relation. So I say height and weight. What is the letter we use for correlation? Can you throw it in the chat? Which letter do we use? You remember that? We have one letter that we say, correlation. The R, indeed. Correlation. So indeed, the R. And in your null hypothesis, you say, okay, height and weight, the correlation will be 0. I assume there's no effect, but I'm going to formulate my own hypothesis to battle against this. And I say, well, I think height and weight, the correlation is not 0. I think there might be a correlation, and I'm going to test those two hypotheses against one another. I'm interested about the entirety of the Netherlands, but I don't have time to measure everyone in the Netherlands, so I'm going to do just measure you guys. And in my sample, so you guys, I find a correlation of 0.8. Is this a strong correlation, weak correlation, or medium correlation? Can you throw it in the chat? Yeah. Strong, medium, or weak? This is a strong correlation, indeed. Bit tricky, but for your exam, you actually have to be able to tell that quite accurately. So for correlation and for coherence D, you have to be able, not based on 0.005 or something like that, but you have to know 0.8 is strong. And in correlation, 0.6 is still considered strong. Okay? So you have to... Okay. So in my sample, with you guys, I find 0.8 correlation. So I find a strong correlation between height and weight with you. That's good news. I like that. Well, the thing is, I have to now calculate the p-value. And the p-value, try to remember that as your problem value. This is the probability, p, probability, problematic value, that what I found, 0.8, is purely on accident. So in other words, it's great that I find 0.8, but this could just be coincidence, right? That you have a very strong correlation, but that in the Netherlands there's no correlation at all. So your p-value is your problematic value, the probability that you found your effect on accident. That is a coincidence. That is not the case in the Netherlands, actually. In statistical terms, it's the probability of finding your data, 0.8, given that the null hypothesis is true. So that although I found 0.8, in fact it's 0. Do you then, if you hear this, you can throw it in the chat, do you want your p-value to be high or low? Can you throw it in the chat? Low, indeed. Why? Easy way to remember, your p-value is your problem value. And you want your problem value, because it's a problem, to be low. Important to remember, because correlation you want to have that high. Cohen's D you want to have that high. Number of participants in your study, high. Everything should be high except for your p-value. That should be low, because it's a problem value. You want that as low as possible. Theoretically, why? Because this is the chance that this, what you found, is purely a coincidence. Purely coincidence. P-value, pure coincidence. PP. And obviously you don't want this to be coincidence. You want this to be maybe true. So you can actually say that in the Netherlands there's also a strong correlation. Before we continue, can I see in the chat, is this clear? Can I see yes, no, or moi? Because it's important for your exam. So I want to make sure that you get it. And you should just be honest. In the chat, yes, no, moi. I see some private yeses. Also for the rest, if I see enough yeses, I'm going to continue. Okay. But let me know, eh? Because it's important. Because we're also going to be seeing later how this is going to be examined on your exam. For now, remember, p-value you always want as low as possible because it's a problem value and it's the chance that what you found was coincidental. That it was not actually the case in the Netherlands, but only in your study. It's probably a coincidence. Okay, probably a coincidence. So you want your p-value as low as possible. How low do you want this? We established in science that we want a p-value that's smaller than 0.05. And what does this mean? Like I said, the p-value is a probability, so it's a chance. And 0.05 means 5%. 0.5 is 50%. obviously. 0.05 is 5%. So what does this mean, actually? This means that I say, okay, if you find a correlation, if I find a correlation with you guys, and if I can show that the chance that that's purely a coincidence is smaller than 5%, then it's statistically significant. Because then I can say, okay, I found a strong correlation, and the chance that that's purely a coincidence, smaller than 5%. And that's great, because then I can kind of say with, well, 95% certainty that this might say something also about the Netherlands as a whole. If that's the case, it's statistically significant and we reject the null hypothesis. So we go all the way back. The null hypothesis saying there's no correlation. I say, well, I found 0.8. That's not a coincidence probably. So screw you and your null hypothesis. I think it is actually the case that there is a correlation. If not, if my p-value is higher than 0.05, so if I have a high p-value, then basically to say, okay, fun that you find 0.8, but the chance that that's purely coincidence is too big, so you cannot assume that this is actually the case, and I have to maintain my null hypothesis. I have to keep assuming that there is zero effect. One more thing that's important, sometimes they ask you in the exam quite a tricky thing. They say, okay, well, I find a correlation 0.8. My p-value is smaller than 0.05. All good. What can I now say? And then one of the answer possibilities would be, I can prove that my hypothesis 1 is correct. The word proof, you can never prove in science. You can never know something 100% sure. You can support your H1, but you cannot prove it. So if you see the answer possibility prove, that's wrong, okay? And that's very important to remember because you can remember all of this and then you can still go for the wrong answer possibilities. You can't prove. You can't know with 100% certainty. Your p-value can never be exactly 0 because it could still be purely coincidental. Is this clear for everybody? Can I see a yes or no in the chat? And otherwise, even if you say, I want to see it again, just tell me in a break or something like that. I can just, even if you don't have a particular question, like I said, I can explain everything 1,000 times. I don't mind. Because this is just very important. And I spend a little bit more time with this because this is just the basis of your entire bachelor. So you really need to grasp this. It's going to help you with statistics as well. Okay. The difference between a confound and an obscuring factor. You can kind of ditch all these kind of rules. You can read them. That's why I put them on the slide so you can check them later. But the best way to remember the difference between a confound is there is an effect, but that effect is explained by something else. Smoking, hangover, but it's explained by drinking. That's a confound. We already saw that. An obscuring factor, remember that obscuring is an obstacle. Obscuring obstacle. Obs. So this means there might be an effect, for example, gender on mathematics. Let's assume that women are better at mathematics than men. So let's say there is an effect, gender on mathematics, but because of an obscuring factor, because of an obstacle, I cannot find that effect. So that could be, and we're also going to see some examples, that for example, my test is way too easy. So I make such an easy test for mathematics that all my men score a 10 and all my women score a 10. So although women are generally better at mathematics, because of an obscuring factor, because of an obstacle factor, I cannot see the effect anymore. Okay? We're going to be practicing a little bit with this later, but that's the difference between those two. Okay. Bear with me on this part because people also find this tricky. I particularly chose tricky topics, obviously, because I can explain everything that's obvious, but it doesn't help a lot. Okay, let's continue with the example of men and women on mathematics. So let's say I have men and I have women. Okay, how can I easily say that gender has an effect on mathematics? What do I want in my research? We're going to start off with differences between conditions. In other words, I want my women to have a higher score. Let's say they score on average a 10, and my men score on average a 1. That is good news. If there's a very big difference between my conditions, between women and men, then I can say, okay, gender might play a role in mathematics because on average, my women score way higher. So between conditions, between men and women, you want a big difference to be able to establish an effect. Okay. If the difference between your conditions is too small, that's a problem. Let's say all my men on average score a 10 and my women also score on average a 10. If they score the same, then I cannot say very easily that gender has an influence on mathematics because my men and women score the same. How can this be? This can be because of a weak manipulation. And examples of weak manipulations are ceiling and floor effects. A ceiling effect means that everyone scores against the ceiling, which means they score too high. So this would be that my mathematics test is one question, which is what is 2 plus 2? Well, all my men have this correct, they score a 10, and all my women have this correct, they score a 10. So I suddenly cannot see the difference anymore between men and women. Other way around, floor effect. Now I give you a mathematics test, but it's way too difficult. Like it's equations that you're not able to solve. It's like the Technical University of Eindhoven extended mathematics course. So all my men score a 1 and all my women score a 1. So once again, the difference between my groups is now too small and I cannot see what the effect is of gender. Before I go to within conditions, is this one clear? Can I see a yes or no in the chat? Are we also going to see some exam questions with this later? Yes or no? Clear difference between conditions? Chat. Okay. Otherwise, I trust you will stop me. Okay. This is important to grasp. Difference between conditions. You want them big. Now, and this is the other way around, spread within my condition that you want as small as possible. What do I mean with this? Within my condition. So within my group of men, this is not great. If one man scores a 10 and the other man scores a 5 and another man scores a 1, if within my group of men they all score all over the place, then I cannot say that men generally suck at mathematics because it seems to depend on the man. So there's not a strong effect of gender. If it goes all over the place within my group, that's not a great thing. Generally, what you want in an ideal situation is that all my men score a 1 and all my women score a 10. Because then the difference between my conditions is huge, 10 and 1. And within my conditions, I can really see, oh, all my men score a 1, so gender must play a role here. And all my women score a 10, so it must really have something to do with them being a woman. Okay. It's so important to remember that. Within your conditions, you want as little spread as possible. Between your conditions that you compare, you want a big difference. Because in this example right here, this is the easiest way to say gender has something to do with mathematics. Well, If my spread within my conditions is too wide, so let's say, like I said, one scores a 1, 7, and 1, so it goes all over the place. How can this be? Individual differences, like I said, one man is just better at mathematics than the other. That's a problem, because then I cannot say it has anything to do with gender. Other reason is accidental measurement errors. If I make mistakes in measuring mathematics, yeah, then the scores are going to be more random, and then the chance is bigger that it's going to vary a little bit within my group. So I want to measure accurately. And thirdly, environmental influences. Noise. Not nice, noise. Environmental influences, for example, if I give you this mathematics test, but if I give you this in the Amazon rainforest, what's going to happen? One man might be very distracted, so he scores a 1. Another man might be so motivated to get there out as quickly as possible, so he's going to try his best and score a 10. Another guy gets sick halfway, so he's going to score a 7. So environmental influences also creates the randomness within a condition, which is a problem. And the same goes for my women, eh? My women will also score all over the place. And then it's more difficult to establish if there's an actual difference because it's more random. Is this clear for everybody? Can you see yes or no in the chat? If I see enough yeses, I will continue. I have to explain it again because this is important for your exam. So please tell me yes or no. Brutal honesty, Dutch directness. Okay, I see I'm not sure. Okay. For the rest, let me establish. Noise is indeed unsystematic variability. So that means indeed not a systematic change, but unsystematic. So indeed like random noise. Indeed. Okay, so one not sure for the rest, yes or no? Then I have to kind of establish if I explain it in the break or explain it now. Is there a specific part, Mina, that I can explain again for you? Good that you tell me that. Otherwise, what I will do is just the difference between those two again. So between conditions and within conditions, right? Okay. I also see another not really. Okay. Okay. So I'm going to explain it once more. Between conditions means that we have two conditions. Let's say two groups. So let's skip the word conditions and use the word groups because it's the same thing. Difference between groups. So difference between my men and between my women. Takeaway message here for your exam is that you want the difference between your groups to be as big as possible. Because you want your men, for example, if all your men score a 1 and if all your women score a 10, if that's the case, this is good news because then I can really say, look, women are better at mathematics than men because they score a 10 and men score a 1 on average. So there's a huge difference between those groups. Good news. We want those to be as big as possible. This is obviously the sad emoji. We don't want it to be too small. We want it to be big. Within my condition, so within my group of men, and this is an important nuance, there I want the difference to be as small as possible. Why? I want my men to all score the same. Because if my men don't score the same, if one man scores a 10, another scores a 1, and another scores a 7, then I cannot say that it has something to do with being a man, because they all score different. And I want to see gender on mathematics score. So I want all my men to score the same, and all my women to score the same, and then I want all my women to score big, and all my men to score low. Because then I can say, well, if I measure 1,000 women, and if they all score a 10, and 1,000 men, and they all score a 1, then gender must really have something to do with mathematics skills. Is it more clear like that? Can I see yes or no in the chat? You can just be honest. I can also discuss it in the break. We're also going to practice with this, so that might also help. Okay, and if you have any particular questions, let me know. It's good that you tell me that. Because that might also encourage other people to indeed ask if it's not clear, and then I can explain it again. Okay, quick recap, but good to remember. How do I get significant results? As many participants as possible. The more people you test, the bigger the chance for a significant result. Because if I test 17 million people, the chance that my result is purely accidental, so that my p-value is too high, well, the chance is very low. If I ask 17 million people, chance that that's an actual result is more likely than when I ask only one person, because then it might be purely coincidence. You want as few individual differences as possible. You want all your men to score the same and all your women to score the same. Measure reliable, making environmental influences as small as possible. The more artificial it is, the better. And this might sound weird, but if I test in a lab, then I can control a lot of confounds. And that's a good thing. So these two are a little bit connected. In a lab, there's less influence from the environment, so that's better for a significant result. Use a strong manipulation and prevent ceiling and floor effects. Ceiling effect being everyone scores against the ceiling, so too high, everyone scores a 10. Floor effect, everyone's on the floor with the result, scores too low, everyone scores a 1. Then it's difficult to establish a significant result. Okay. Before we go to, let's see, what are we going to do? First, I'm going to give you this exam question, and then I'm going to explain to you moderators, mediators, confounds, and then we're going to have a little break. So read this question, and if you know the answer, or if you want to see it discussed, one of the two, say yes in the chat. Not A, B, C, or D, but just yes, because people want to maybe think for themselves. If I see enough yeses, I will discuss it. Otherwise, I won't. So let me know. Take your time. Really try to think what happens here. Men and women on a mathematics test. Try to keep using that example. See a few yeses coming in. We'll wait for a few more people. Okay, we have about 50%, and we'll wait until we have 75% of the people. Also, if you find it difficult, but if you want to see it discussed, you can just say yes. Okay, also privately, I see some yeses. Okay. Okay, let's start. So let's start with answer possibility D. A weak manipulation can cause variance within groups to be too large. just write down for yourself what is actually written here. A weak manipulation means that I create something that doesn't really have a strong effect. So a ceiling or floor effect is an example of that. Another example could be that I want to see if men or women are more scared generally. And I manipulate this by saying, boo, like not really that scary, right? Not really that terrifying. So none of them are going to be very impressed. If I do that, well, all my men are going to say, I'm not scared. And all my women are going to say, I'm not scared. They always score a 1 because they're not scared. And that means, okay, can cause variance within groups, so within my group of men, to be too large. No, the variance within my group of men is very small because there's no variety at all within my group of men because they all score the same. So this is not correct. A ceiling effect may cause variance within groups to be too large. A ceiling effect, everyone scores against the ceiling, so everyone scores a 10. Variance within my group of men to be too large. No, there is very small variance within my group of men because they all score the same. Environmental influences may cause differences between groups to be too large. This is a tricky one because in theory it could be, but environmental influences just create randomness within groups. So that means, like I said, I give you a mathematics test in the Amazon rainforest, and one person is so terrified to score a 1, the other person loves it and scores a 10, and the other person is a little bit in between and scores a 7. Which means that within my group, it goes all over the place and it's more difficult to establish an effect. But this is mostly influenced in within my group because for my men, it could be that the same thing happens. But it could also be that all my men love it and all score a 10. So it's mostly focused on within my group. All my scores are going to be all over the place, so I cannot really say anything about the women or men because they all score very different. A floor effect, everyone scores low, can cause differences between groups to be too small. Yeah, if all my men score a 1 and if all my women score a 1, they score an average of 1, they also score a 1, no difference. So that's a problem. I cannot say anything because they score the same. So the correct answer is answer A. Is this clear for everybody? Can you see yes or no in the chat? Okay, this is how you can expect it on the exam. You will indeed get the slides later. Yeah, okay. I suggest, because we are now almost an hour busy, an hour approximately, that we are gonna take a small break so that you can breathe. So let's say we do that. I have a little bit of a time difference. I think it's hour early with you. So let's say 10:35. Should make sense, right? 8 minutes. So 8 minutes, just get some coffee, take some rest, and then we're going to be discussing this and some more exam questions. If you have any questions in the meantime, you can just already throw them in the chat and I will answer them once I'm back. Okay? 8 minutes and then we're going to continue. All right, 35. So we're gonna continue. For your exam, it could be that they give you a little story, and in that story you have to be able to establish if they're talking about a confound, a moderator, or a mediator. So you have to know the difference between these three. A confound we already saw, so I'm going to give you the most classic example, but we can see a relationship between ice cream and drowning. So the more ice cream is sold, the more people drown. And a confound says, okay, that's fun and all, but that effect is because of something else. So the fact that the sun is shining improves ice cream sales and makes that more people drown because they go swim in the ocean. So a confound influences both factors directly. A moderator is a little bit more tricky. A moderator, maybe you know it from Reddit, for example. If you ever see Reddit, you have moderators on Reddit or on a forum, which is basically someone moderating the discussion. So influencing the discussion. And that's what a moderator does. So bear with me, very important for your exam and quite tricky. That would be, for example, that we see that if the sun is shining, generally more people drown, but this effect between sun and drowning is moderated by the wind, which means that the effect between sun and drowning is dependent on how much wind is blowing. Because if there's a lot of wind blowing, then the effect might be stronger. And if there's even more wind blowing, like a hurricane, then it could be that people don't swim at all, and the effect might be even smaller. So this means that there's a third variable that influences the relationship between sun and drowning. So here, the relationship between ice cream and drowning is kind of nonsense. It's kind of bullshit and only to be explained because sun influences both. Here there is an actual effect of sun and drowning, but how strong that effect is, of how that effect works, depends on wind. Would you guys, you can say yes or no in the chat, would you guys like one more example? Or is this clear? One more example? Yeah, that's what I thought. Well, let's say when I started working at my organization, they introduced me to the IT guys, and they said, well, the IT guys, they are very silent. They don't talk. A little bit introverted, they don't talk. Okay, so they say, like the IT guys creates basically the fact that they are silent. Okay. A moderator says, well, that effect depends. For example, on conversation topic. Because yes, they might be a little bit introverted and they don't talk a lot, but if you talk to the IT guys at my organization about Star Wars or Lord of the Rings or something like that, then I trust me, they're not gonna stop talking anymore. So yes, there might be a general influence between IT and not talking a lot, but the effect on that depends on the conversation topic in this sense. Okay? Another example, I sometimes visit LiveLeak. This is this website which is basically like YouTube, but with all the videos that are not allowed on YouTube. So things going wrong, essentially. So, for example, there's this. Then you watch a little a clip. So you watch a little clip, and in that clip, you see that someone tries to jump from with a car from one roof to the other roof. Okay. Well, that goes wrong. Quite often it's in Eastern Europe that goes wrong. The car falls down. Someone might die. You never know. They never show that, but it's kind of like, well, tricky. And then you can say, okay, if you watch that clip, what is the chance that you're gonna do that yourself? So that you're gonna imitate what you see. And then you could say, for example, that, well, if you're gonna do that, yes or no, that might depend on gender. Women might be a little bit smarter. They tend to live a little bit longer. If they watch that clip, the chance that they're going to do that themselves becomes smaller because they see how it goes wrong and they say, okay, I'm not going to do this. Where men might be overly ambitious, watch that same clip, and because they watch that clip, they are more inclined to try it themselves because they are overly ambitious and they feel, well, I can surely do this properly. And they're going to try that with the car and they also fall down the ditch. Is this clear for everybody? So in your exam, it's really about, is there a third variable that influences both, or is there something that influences the effect? And you can also kind of see the difference if you write it down like this, because this is not a confound, because a confound, that would be this, and that doesn't make sense. That is that the topic of conversation influences if you work in IT, yes or no. That's not how it works. So by writing it down schematically like this, you can automatically see if it works, yes or no. Is this clear? Can you know in the chat? And this is important, so give me input. And then, because then I continue with a mediator. This is a moderator. So this moderates the effect. Also for the rest, yes, no? Just tell me, eh? I just have to assume, which is more tricky. Okay, I see some private yeses. Let me check. Okay, all right, nice. Then we're going to continue with a mediator, and then I'm going to summarize it once more. A mediator is something in the middle. So, for example, sun influences drowning. Okay, but this is true swimming. So this is how you write that down. Yes, sun influences drowning, but this is only if people go swimming. Because if you're at the top of the mountain and the sun shines, well, then there's no chance of drowning because you're not going to swim because there's no water there. So a mediator's always in the middle. So a mediator looks like this. Sun influences swimming and that influences drowning. But if you would leave swimming, if you would take that out of the equation, then sun doesn't have any influence on drowning anymore. So this means there is an effect between one and the other, but it's only influenced through a causal factor in the middle. So in your exam, if they give you a situation, just try to see, is it a third factor that influences both? Confound. So that this is kind of like a bullshit relation, and it's influenced because of a third variable that influences both. Sun influences ice cream and influences drowning. Confound. If it's about the effect that changes because of a third variable, so either it becomes stronger, weaker, or reversed, doesn't matter, that's a moderator. So yes, there is an effect, but this depends on a third factor. And lastly, if they say, okay, there is an effect between one factor and another factor, but this is explained by another factor in the middle, that's the mediator, the middle. Clear for everybody? Yes, no in the chat. Mediator, I think, is a little bit easier to grasp than moderator. This is one in the middle. Okay, perfect. Well, we discussed this. This was answer A, and now I'm going to give you another question. Take your time for this. I will remove my notes. And you know the drill. Tell me yes in the chat if you know the answer or if you want to see it discussed. I see the first yes. Indeed, let me know if you're finished. If I see enough yeses, I will discuss it. Typical exam question this. You have to combine multiple concepts. Okay. Okay, let's see what we have here. At the end of an experiment, it shows that many subjects, so many participants, have achieved a maximum score on the dependent variable. The dependent variable is the thing we measure, eh? So that's the thing. Therefore, does that means, so it's the thing afterwards. So that makes sense. Okay. Dependent variable. What could this mean for the results? So they all score a maximum, have a maximum score. So let's say all my men have a 10. No, and we don't know if it's two conditions, but based on C and D, we can assume there are multiple conditions. They all score a 10 and all score a 10 because they achieve a maximum score. That the dispersion within conditions increases. Dispersion is just another word for spread, but it could be that they use this word on the exam, so I threw it in there. Dispersion within conditions increases. No. Within my group of men, there's not a lot of difference. They all score the same. That the spread between conditions increases. No. My men score an average of 10 and my women also 10, so no. And then the only question remains, how can I now find a significant result? So for example, that there is a difference. Well, they all score the same. So I cannot say that there is a difference. So significant results are less likely to be found. If everyone scores the same, then I cannot say that gender in this case has something to do with mathematics, for example. Is this clear? Can I see a yes or no in the chat? This is how that works. So always think, what does this mean practically? This indeed is the ceiling effect. Well done. Maximum score, they all score against the ceiling. It's also an obscuring factor for that matter. There might be an effect, but I can't see it because of an obstacle, an obscuring factor. And the specific obscuring factor is indeed the ceiling effect. Well done. Okay. So always really try to write this out. What does this mean concretely? It doesn't really help to remember all these rules by heart. Think of a practical example. Dispersion is just a different word for spread. Yeah, or variety for that matter. Yeah. Okay. Same thing. But sometimes I use these words interchangeably in your exam. So I also throw them in interchangeably so that you get used to them. Okay. Good that you ask. Okay. Then we're going to continue to part 2. At the end, I will also show the QR code, but I think most of you guys are already in the group chat, but then you can still join. Okay, now we're going to look at interactions and main effects. Very important. A lot of people find this tricky. Let's start off with what is an interaction. So far, what we've done, and I will write it out, is constantly took the same example. I said gender on mathematics. In a factorial design, that's what we're going to see. In a factorial design, we add another factor. That's why it's called factorial. So that means and then I'm going to see how do men and women score, how do young and old people score. Okay. In interaction, basically says, okay, how do these three factors interact with one another? So in other words, it could be that women are better at mathematics than men, but that this is only true for young women. And that for old women, it's not the case, that suddenly then men become better again. So that's an interaction effect. It means that those two factors interact with one another. For your exam, what you have to do is they could give you a graph or a table. And based on those graphs or tables, you have to be able to tell, is there an interaction here and are there main effects here? And we're going to start off with interactions based on graphs. And before I'm going to explain how you do it, I just want to see if you would already be able to answer this. In the left graph, you can throw it in the chat. Is there an interaction here, yes or no? So right here, interaction, yes or no? Throw it in the chat. Maybe you haven't discussed this yet, so then it's quite difficult and you have to guess it. But still, active learning, it's important to try to think. If you don't know the rule, it's very tricky. So I'm going to explain to you the rule, how to establish this. Interaction based on the graph is all about if the lines run parallel. So completely like this, or like this, or like this, or like this, but the same direction in the same slope. If they run parallel, there is no interaction. In all other cases, there is interaction. So if you get a graph like this, you just have to see, do the lines run parallel? Well, they don't. So therefore, there is interaction. Then I'm going to ask you another question. Based on what I just told you, in this right image, is there interaction, yes or no? Okay, throw it in the chat. What do you think? Yes, indeed. Because the only case when there's no interaction is if the lines run exactly the same. So I will write it down, write it out. So now there is no interaction because they run exactly parallel. And well, assuming that they are straight, now there's no interaction. All other cases, there is interaction. And it's not about if it crosses yes or no, it's about parallel. Okay? So some people think if it crosses, it's interaction, otherwise it isn't. Well, if it crosses, there is interaction. But also, if it's like this, they don't cross, still interaction, because they're not parallel. Okay, only if they're exactly same straight parallel, no interaction. All other cases, there is interaction. And those you don't have to calculate. You can just read it from the graph. We're going to practice with this quite a bit. But before we do that, let's go to a little bit of theory, what we are doing now, what we're doing today. So we are looking at the factorial design, like I said. You add multiple factors, gender and age, and I'm going to look, how does that work on mathematics? So I have two independent variables, two things I initially measure, initially independent, I, gender and age, and I'm going to look how they influence the dependent variable, mathematics. Okay. A participant variable is something that cannot be manipulated. So this is something that is part of your participant. That's why it's called like that. So for example, age or gender. If you are in my research, I cannot say, okay, for my study, you're now a man. And for my study, you are now 20 years old. No, that is part of your participant and you cannot change that. A little bit of theory, but that's a concept that sometimes gets examined. So part of your participants that you cannot change. Factorial designs help us with external validity. Why? What is the question connected with external validity? That is, okay, let's say I see that women are better at mathematics than men. Can I now also externally apply this somewhere else, externally else? Well, if I add more factors, so for example, age, then I can tell more about it because then I can say, well, you know, women are better at mathematics, and that's also the case for older women, or for Belgian women, or for French women. So adding more factors helps with our external validity, being able to tell something about other situations, about situations somewhere else. And lastly, before we dive into calculation, levels. A level is something of an independent variable. So for example, my independent variable could be temperature. So I want to see what is the effect of temperature on aggression. And then such an independent variable can have multiple levels. For example, cold and hot. Then it has 2 levels. Or cold, medium, hot. Then it has 3 levels. Is this clear for everybody? This is the background theory. Before we dive into it, can I see yes or no? Okay. Okay. Okay, we're gonna do this step by step. We're gonna start with a two-way design. What is a two-way design? This is basically that I have 2 independent variables. So the example that I just gave. So let's say we're gonna ride along. We have one independent variable, which is gender, and we have another, which is age. And that is basically, we're gonna see how does that influence mathematics score. Okay. Well, basically, we see here that gender, okay, that's one independent variable, I do in 2 levels. I have men and women. What kind of a design is this then? You write down a 2, because you have men and women, 2 levels. Age, I also have on 2 levels, young and old. So what I write down is another 2, young, old, 2. This is what we call a 2 by 2 design. It could also be that I say men and women, and that I say for age, young, medium, old. And then it would be a 2 by 3 design, because I measure this on 3 levels. Different kind of designs. In your exam, it could be that they give you an example and that you have to tell them how many independent variables are there. For independent variables, what you have to do is just look at how many numbers you see. You don't have to calculate anything, just count. So I see one number here, so this is an independent variable, age, and one number here, gender. So I have 2 independent variables. Just look at how many numbers you see. Could also be that they ask you, how many conditions do you have? So how many groups do you have? Well, if you have a table like this, you can quite easily see it, because we have, let's say this is old, young. We have old men, that's 1. We have young men, that's 1. We have old women, that's 1. And young women. So we have 4 conditions, 4 groups. Easy way to also do this is you can multiply. So if I show you a 2 by 2 design, as I do here, you can do 2 times 2 is 4. You have 4 conditions. Based on that, throw it in the chat. How many independent variables do I have here? Throw it in the chat. Even if you're in doubt. How many independent variables? 2. That's exactly correct, because we just see 2 numbers. So this is men, women, and young, middle, old. 3 levels, okay, with 2 independent variables. Indeed, we measure 2 things. And how many conditions do I have here? Show it in the chat. We multiply. 2 times 3 is 6. Okay. Then I'm going to give you one more example. 3 times 2 times 2. How many independent variables do I have here? Throw it in the chat. Try to think, eh? That's the best way of learning, to really try to get it out of your memory. How many independent variables do I have here? I see some private answers, but also the rest. Look at how many numbers do I see. So I see 3 numbers. So 3. So it could be that this is, for example, men, women, young, old, and favorite color, red, blue, green. 3 levels. How many conditions do I have here? This is things that you can get for your exam. With conditions, we multiply. So 3 times 2 is 6, times 2 is 12. They're not going to give you difficult calculations because you're not allowed to bring a calculator, but you have to be able, based on those such numbers, to tell them how many conditions do we have. You could also write down the entire graph, entire table, but that's a little bit unnecessary. You can just calculate it by multiplying. Okay. One more. 3 times 4 times 2. How many independent variables do I have here? Indeed, just look at how many numbers are written. 3. So I measured 3 things, 3 independent variables. How many conditions do I have? Give you some time to calculate. 3 times 4 times 2. 24. Exactly. That's how many conditions I have. So that would mean how many groups I have, basically. So this could be, well, men, women, other, young, old, and nationality, Dutch, Belgian, French, German. And then you have in total 24 possibilities. You have old Belgian women, you have young Belgian women, you have old French men, etc., etc. Then you have 24. Yeah. Okay. So one step further, that was a two-way design. So then we have 2 independent variables. Now we're going to look at a 3-way design, and you can have this basically until a million-way design. But just so that you see what that would look like, that would mean I measure 3 things. Or I have 3 independent variables. So could be male, female. So that's 1. So if you get a situation like this, you just say male, female. Okay. 2 levels, you're either male or female in this scenario. You're either old or young, so also 2 possibilities, and you're either happy or unhappy. So this is a 2 by 2 by 2 factorial design. And then I'm going to see, for example, how you score on mathematics. Do old happy men score different than young unhappy women? Well, then I can fill all of these in. And as you can see, 3 independent variables. Male, female is 1, old, young is 1, happy, unhappy is 1, and 8 conditions. But you could also just calculate that 2 times 2 is 4, times 2 is 8. Before we go to main effects and interactions, is this clear for everybody? Can I see yes or no? How you would do this in the exam? So it could be that I just give you a design number like this. Most often what they do is that they say a situation like this. I measure male and female. I measure if they are old or young. And I measure if they're happy or unhappy. How many conditions do I have? And then you just ride along. 2 times 2 times 2 is 8. Okay. Also for the rest, clear? Can I see yes, no in the chat? Good, good, good. Now we're gonna look at main effects. And I need you to stop me if it's challenging. But the good thing is we're gonna practice this quite a bit. We're gonna look how we calculate based on tables. Like I said, there are basically 4 things they could ask you on the exam. And most often they ask you 2 out of 4. So that's already 2 exam questions that you have correctly. And sometimes even more, but most of the times 2 out of 4. Interaction based on a graph. We already covered that. Parallel, yes or no, right? If it's parallel, no interaction, all other cases, yes. After this part, we're gonna see main effects based on the graph. And now what we're gonna do is main effects and interactions based on the table. Those are the 4 possibilities. Okay, bear with me with this one. Because it looks more tricky than it is. Main effects. Let's say this is Milgram. This is the experiment of Milgram, where people gave shocks to other people. So my dependent variable is how hard a shock I gave. And what I want to see is, okay, is the influence, does body weight matter? I think maybe heavy men give heavier shocks. And does it matter if men are drunk? Yes or no? So how many independent variables do I have here? Can you throw it in the chat? Just to see if you got the last bit right. I see it in the private chat as well, yeah. Independent variables is just how many things initially influence the other thing. So basically, that's 2. We have body weight and drinking condition. And we have body weight on 2 levels, light or heavy, and drinking on 2 levels, placebo or drunk. So this is a 2 by 2 design. 4 conditions, 1, 2, 3, 4. Okay. All right. Okay. Now what they could ask you on the exam, and they're not going to give you those kind of tricky numbers. We're going to practice with it later. They're going to give you easier numbers, but just so you get a grasp, what they can ask is, okay, is there a main effect for alcohol? Let's start with that. And what they basically say, regardless if you're light or heavy, ignore that completely. I only want to know if it matters if you are drunk, yes or no. I only want to check out the effect of alcohol, the main effect of alcohol. And a way to remember that is that the main effect is the mean effect. So the average. We are calculating averages here. So bear with me. Let's start with my placebo group. Okay, we follow the table. Sometimes they score a 5.09. Okay, sometimes they score a 4.72. I take the average, so I add them on top of each other divided by 2. This is my average. So sober men score 4.91 on average. Okay. What about my drunk man? My drunk man sometimes score a 6, sometimes a 7.19, average 6.60. Is there a difference between those numbers? Yes. So, does it matter if you're drunk or not? Yes, drunk men on average score higher than sober men. So, is there a main effect of alcohol? Yes. Drunk men score higher than sober men. Okay. Before I continue to weight, we're going to do this in the same way. Is this clear? Can I see yes, no, or moi in the chat? Because I will do that makes how fast I will do the other one. Okay. Okay. Well, now the other question they could ask is there a main effect of weight? Does it matter on average if you're light or heavy? Same way. light men, we see them right here, eh? They sometimes score a 5.09, sometimes a 6, average 5.55. Heavy men, sometimes a 4.72, sometimes a 7.19, average 5.96. That's a different number. That's the only thing you have to establish. Doesn't matter how big that difference is. If there is even a tiny, tiny difference, then there is a main effect. Heavy men, on average, score higher than light men. So yes, there is a main effect of alcohol. Alcohol matters. And yes, there is a main effect of weight. Okay. We're going to practice with this later. But before we're going to do that, I'm also going to show you how we do interactions. Because we can also do interactions based on tables. This is how you do that. So remember, by heart, main effect is mean effect. Then we're going to calculate means, averages. Interaction is min-interaction, like minus. So, min-interaction. Because now we're not going to work with averages. We're going to subtract numbers from each other. We're going to do minus, min-interaction. How do we do this? Let's say you get example like this. How can I establish if there's an interaction? We take one number and we just subtract it with another number. 5,551 minus 562 is minus 11. And now we're going to do the same direction, so from top to bottom. For this, 559 minus 552 scores 7. Those are different numbers, therefore there's interaction. Same with main effect, if there's a difference, then that's the case, then it's present. So there is an interaction here. You can also, and that's interesting, but you don't have to do that. It doesn't matter if you go from top to bottom, or from left to right, or from right to left. All the same thing. So let's do that. Let's say I go from right to left. 559 minus 551 is 8. 5, we have to be consistent. So now I also have to go from right to left. 552 minus 562 is minus 10. Different numbers, therefore there's interaction. It's always, it doesn't matter which direction you go to, either it's all different or it's all the same. So it doesn't matter. You don't have to check all possibilities. If one of these directions is different, interaction. If one of them is the same, no interaction. Before we're going to practice with this, is this clear for everybody? Can I see yes, no, or moi in the chat? A moi is also okay. If I see a lot of yeses, I do it quicker. If I see a lot of no's, I do it slower. Throw it in the chat. Okay, we see some yeses in the private chat. Okay. Otherwise, let me know, eh? And we are going to practice with this right away. Well, like I said, doesn't matter which direction you go into, doesn't matter. Little bit of repetition. On the left graph, is there an interaction? Yes or no? Throw it in the chat. Yes, indeed, there is interaction. Why? Because the lines don't run parallel. They don't run exactly the same way. On the right graph, is there interaction? Yes or no? It's maybe tricky to see. I see a difference in answers. It's very tricky to see, and they're not on the exam. They're not going to make it so close that it's almost impossible to see. But if you can see it, the orange line doesn't run exactly parallel with the pink one. So, although it's difficult to see, there is also interaction here. If you find that easier, what you can also do is extend the line. And then you will see that eventually, well, now it goes off my screen, but if you do this long enough, they will cross. So they're not parallel completely, and they have to be parallel completely. Otherwise, there is interaction. So also here, there is interaction. Yeah. Like I said, this is a matter of centimeters. So if you didn't see this, no problem. But just that you understand the concept, they have to be exactly parallel, not slightly parallel. Interaction in both cases. Okay. I'm gonna show you once more how to do this, and then you're gonna practice with this yourself. Okay, so in your exam, usually you don't get all data like this, you have to calculate it. But for now, I'm gonna show you how we do it like this, and then we're gonna make it more difficult step by step. Is there a main effect for phone use? Okay. What did they ask? They basically say, regardless if you're a young driver or an old driver, doesn't matter if you are on your phone, yes or no. If you're on your phone, sometimes you make 10 accidents, sometimes 4, average 7. 14 divided by 2. If you're not on your phone, sometimes 10 accidents, sometimes 4, average on 7. Ask question for you, throw it in the chat. Is there now a main effect for phone use, yes or no? No, exactly. Because on average, it doesn't matter if you use your phone, yes or no. So, no, no main effect for phone use. Okay. Is there a main effect for age? Sometimes young drivers score a 10, other times they score a 10, on average 10. Old drivers sometimes a 4, sometimes a 4, on average a 4. Doesn't matter if you're young or old? Yes. Young drivers on average score higher than old drivers. So is there a main effect for age? Yes. Lastly, is there interaction between age and phone use? Interaction, minteraction for minus. 10 minus 4 is 6. So write it down here. 10 minus 4 is 6. Same result, so no interaction. And we can also see that from the graph here. Lines run perfectly parallel, no interaction. No, yes, no. Okay? And now you're going to do it yourself with different numbers. So you know the drill. Tell me yes once you have the answers or once you want to see it discussed. Is there a main effect for phone? Is there a main effect for age? And is there an interaction between age and phone use? Take your time and say yes in the chat once you're done. Okay, see the first yes is coming in. I'll give you some more time. Okay. About half I have the yeses from. Also, for the rest, I will wait a little bit longer. If you are stuck, I'm gonna give you a little hint. Main effects, mean effects. So you calculate averages, interaction, min-interaction. You calculate minuses. Okay. I see most of you responded with yes. I will wait for one more yes. And then we're about 70, 80%. Okay. We're also going to be discussing this later with an exam question, because obviously, good news, your exam is multiple choice, eh? So it's not going to be examined like this, but you have to be able to do all of this. So the exam question would be A, yes, there is a main effect for phone, but not an interaction effect. B, yes, there are main effects and an interaction effect, etc., etc. But it's the same thing, same concept, only asked in a closed way. I'm gonna show you one later. Main effect for phone use. Okay. Sometimes people that are on their phone, sometimes they score an 8, and sometimes they score 2. So that's 10, average 5. People that are not on a phone sometimes score a 5, sometimes a 5 is 10, divided by 2 is 5. So it doesn't matter if you're on your phone, yes or no, no. On average, they score the same. So there is no main effect for phone use. Main effect, mean effect. Look at averages. Younger drivers, sometimes 8 accidents, sometimes 5. That's 13. On average, 6.5. Okay. Older drivers, sometimes 2, sometimes 5 is 7, 3.5. Doesn't matter if you're young or old. Yes, young people cause more accidents. So is there a main effect for age? Yes, it matters how old you are. Lastly, is there an interaction between age and phone use? Interaction, min-interaction, minus. So 8 minus 2 is 6. 5 minus 5 is 0. Those are different numbers. If they are different numbers, then there is interaction. And like I said, you can also do the other way around. You can also say 8 minus 5 is 3. 2 minus 5, you have to do the same direction. 2 minus 5 is minus 3. 3 and minus 3 are different numbers. The minus doesn't matter. Different numbers. Therefore, there's interaction. And if you would see the graph, you can immediately see it, but quite often you don't get the graph with it. That would be a separate question. So, no, yes, and yes. Is this clear for everybody? Can I see a yes or no in the chat? We're gonna practice what this once more. So if it's not clear now, let me know, and then I can explain it, and then you can practice with it completely independently once more. Okay. I see yeses also in the private chat. Okay, perfect. We're gonna look at that later. So we're gonna show you one more question. But once, like I said, main effects is mean effects, and interaction is about lines not running parallel. A little bit of repetition, but important to remember. Now what we've done, we have 3 out of 4. We have interaction based on the graph, interaction based on the table, main effect based on the table, and the only thing remaining is main effect based on a graph. Gets examined quite a lot. This is a popular one. How do we do this? Well, let's say this is my research, so I want to see how much of the lecture you remember. So that's my dependent variable, the thing I measure, and I have two independent variables, two initiation things that might influence it. Independent variables, you can also remember they are the influencers. They influence the dependent variable. Okay. We have if you are sober or if you drink a bottle of wine, so alcohol. And we have sex, so if you're man or a woman. Okay. Before I explain to you main effects, is there an interaction here? Can you say yes or no in the chat? Yes, there is an interaction because they don't run parallel. They don't run in the exact same slope. They even cross. There is an interaction here. Perfect. You don't have to calculate that. You can just see it from the graph and you can immediately say interaction. If they ask you that on the exam, 3 points. Hooray you. Main effects. Okay, alcohol. Let's start with alcohol. How do we do this? This is my nothing condition. And basically, it's similar to what we already did. If you don't drink, people that don't drink sometimes score 70, and sometimes they score 80. Average, 75, right? 150 divided by 2 is 75. If you drink a bottle of wine, sometimes 10, sometimes 20, is 30, divided by 2 is 15. Is there a main effect? Throw this in the chat. Is there a main effect for alcohol? Can I see a yes or no in the chat? In other words, does it matter on average if you drink, yes or no? What do you guys think? Main effect for alcohol, yes or no? Yeah, it matters because people that drink nothing, they score 75, and people that drink a bottle of wine, they score 15 on average. Same thing with the tables, they're different numbers. So it does matter if you drink, yes or no. Okay. Now we're gonna look main effect for sex. How do we do that? Well, same method. Men are the dotted line. So men sometimes score 70 and men sometimes score 20. Is 90 divided by 2 is 45. Women sometimes score 80 because women are this line. You can read it from here. Sometimes 10. So that's 90. 80 plus 10 is 90 divided by 2 is 45. So throw it in the chat. Is there a main effect for sex or for gender? Yes or no? Does it on average matter if you're men or women? No. No, because on average they both score 45. So, in other words, and I also wrote it down because you get the slides obviously. Yes, there is a main effect for alcohol because people that drink nothing score higher than people that drink a bottle of wine. Is there a main effect for gender? No, because on average they both score 45. And is there an interaction? Yes, because the lines are not parallel. Okay? Once more, is this clear for everybody? Can you see yes or no in the chat? Because if you cover this, that means that you basically have all forms covered, and that's going to save you quite a few points on the exam already, especially in combination with the other concepts that we discussed. This is going to help quite a bit. I can assure you that. Can you explain gender again? Absolutely, I can. Gender, basically what we do is you just look at, okay, the question is, Doesn't matter on average if you're men or women. That is the main effect question. Then we first have to know, what does a man score on average? A man, we see here, is the dotted line. So they sometimes score 70, and we'll go one back. Sometimes they score 70, right? 70. And sometimes the man is the dotted line. Sometimes the man score 20. So you take both outsides. 70 plus 20 is 90. Divided by 2 is 45. Women, on the other hand, sometimes score 80. So when they drink nothing, they score higher. But when they drink, they score lower. So sometimes they score 80. We see here. And sometimes they score 10. So that's 90. Divided by 2 is 45. So on average, there is no difference. So on average, it doesn't matter if you're man or woman. Okay? Perfect. Good that you ask. Okay. This is how you will get it in the exam. So obviously, like I said, it's a multiple choice. So I give you time to do this and say yes in the chat once you covered it. If you want to see it discussed, but if you don't know the answer, you can also say no. It's just based on the responses. And if I see a lot of no's, I know to go through the answer slow. So if you know the answer, say yes. If you establish I don't know the answer, say no. What effects are present here? Okay, I see the first yeses coming in my private chat. Give you a few more time, obviously. Take your time. And also, if you don't know it, and if you want to see discussed, just say no in the chat. That's okay. And I will just explain it a little bit slower. I see a lot of no's. And also, if you want to challenge yourself, if you're already done, I will give you some extra questions. You can also ask yourself how many independent variables are here, how many dependent variables are here. I will show it in the chat. What kind of a design is this? And how many conditions? Independent, dependent, what kind of design, and how many conditions? to see if you also understand the basis of it, the theory behind the calculations. Okay, see a few more yeses coming in. I will wait for a few more. Take your time. And also for your exam, those are the kind of questions that take a little bit more time. So that's good for that we practice now, because that's going to save you time for the other questions. Okay. Almost have a majority. One more minute and then I will start discussing it. Also, if you don't know, just say no or yes. It's just a matter of amount of responses and then I will discuss it. Okay. See some private responses as well. I will start discussing it. Perfect. Look at the table below. What effects are present here? Okay. So we start off with establishing cup of coffee or 40 beer. A little bit of a side note. The questions, extra questions that I asked. How many independent variables do I have here? In other words, how many influences do I have here? Independent influence, alcoholic, non-alcoholic, that's one, on two levels. And cup of coffee or 40 beer. So I have two independent variables. This is one and this is one. How many dependent variables? How many things do I measure? Well, it's actually, they never ask this, but because it's all actually always one. You just measure mathematics result. What kind of design is this? A 2x2 design. How many conditions do I have here? 1, 2, 3, 4. 4, or 2 times 2 is 4. Okay. But that's not the exam question here. That's just a little bit of a side note that they could ask in theory. All right. We're going to start off. Doesn't matter on average if you drink a cup of coffee or if you drink 40 beer. You would assume so, huh? But we're going to still calculate it. Okay. If you drink a cup of coffee, sometimes you score 4 and sometimes you score 8. 12. On average, 6. If I drink 40 beer, sometimes I score 3, sometimes I score 1 is 4, on average 2. Doesn't matter on average if I drink a cup of coffee or 40 beer. Yes, cup of coffee score higher than 40 beer. So there is a main effect of alcohol. Okay, there is an interfaction effect but no main effect. Well, that's incorrect because we already found a main effect. Okay, this could be it. Yeah, the other ones could still be correct. Okay, so it's either B, C, or D. That's how far we got. Okay. Alcoholic or non-alcoholic? Well, actually, cup of coffee for the beer. This only says there's a main effect for alcoholic, non-alcoholic. So this is also not correct because there is one for what you drink. So it's either C or D. Okay. Alcoholic. If you're alcoholic, you sometimes score a 4 and sometimes a 3, 7, on average 3.5. If you are non-alcoholic, sometimes an 8, sometimes a 1 is 9, on average a 4.5. So it doesn't matter on average if you're alcoholic, yes or no. Yes. Non-alcoholics score higher than alcoholics. So yes, there is a main effect also for alcoholism and non-alcoholism. I see a question, will there be a recording of the session? I don't think so, but there are also other sessions. So you can also just join another session. Okay, so there is a main effect for alcoholic and non-alcoholic. Okay, so what does that tell us? Rather a main effect. Okay, so that could still be C and D because they say main effects both, main effects both. Now we have to calculate, is there an interaction? Yes or no? Interaction, min-interaction, minus. So 4 minus 3 is 1. 8 minus 1 is 7. Different numbers. So yes, there is interaction. So the good answer is answer D. There is an interaction and a main effect on both conditions. Is this clear for everybody? Can I see yes or no in the chat? This is how you do this. And then you're like properly covered. That's going to save you quite a lot of points. Sometimes like even more than 2, but almost always 2 points. I see yeses. Okay. For the rest also, see yeses. Okay. Otherwise, just let me know. You can just also after class, you can just ask me a question. I will go over it again. That's all perfectly fine. Okay, perfect. Now, that's how we do that. I have some more exam questions, a little bit more theory. But before I do that, I want to ask you, because this is very important for me, to evaluate me. You can evaluate how you liked this course. You can scan the QR code or you have it in your email. I want to ask you to do this. After that, we will discuss some more exam questions, but it's very important for me. What is important is you have a number component and a written feedback. And I just want to ask you, if you don't think it was like a 10 out of 10, you're perfectly entitled to feel that way. But please, 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 please fill in the text what I can do to get to that 10. Because that is for me very important to establish where I am. And that way my manager knows, well, that I tried my best. Because sometimes people say it was perfect and I'll give like a 9. But then, I want to know how to further improve to establish where I am at. So I'll give you a minute to do this. Once I have enough responses, I can continue to the last part. And if you can say yes in the chat once you succeeded, that's also for me to establish. And then we will go to some more exam questions. Okay? I'll give you some time for this. Take your time. And like I said, just tell me what I can do. A C question. Sorry, another question. Are you going to discuss the same concepts in the other group? Yes. Yeah. Yeah. So it's going to be significant testing, main effects, confounds, moderators, mediators, that kind of stuff. I'll take a few more seconds. I see that a lot of you already filled it in. Missing 2 or 3 people. And then we're going to continue to the last part. Okay. Waiting for 2 more people. Okay, okay, okay. Thank you. All right, okay. You can still fill it in, but I have enough responses now, so I have a few. Thank you, by the way. It's anonymous, obviously, but I do see the general results, so thank you for the kind words. That's greatly appreciated. Okay, before we go to the last exam question, some questions because my DM is exploding, so I always just do the frequently asked questions. You will get the slides. Yeah, you also get a summary, I think, from some of the discussed concepts, so you will all get that as well. Quick frequently asked questions thing. For the full course, we have on average 25 people, so it's also going to be small groups. We are right now at 91 out of 100. So we have 1 group left. You can also choose the recordings, which fits 9 people. So if you want to join that, you can. There we will obviously discuss all exam content, makes sense. You get a full summary, 24/7 WhatsApp help, but you can also just ask me questions now if you just, that's perfectly fine. And there's a practice course of 3.5 hours. It's €6 per hour with the discount code. Maverick is not the best chosen discount code. Sounds like a Breaking Bad promo. But with that, I think the full course is like $70 or something like that. And it's like I said, you can also choose a version without the practice course, which is a bit cheaper. So I think can even go cheaper. Oh, there's a discount code for IBA. You can also use that. Okay, yeah, feel free. I mean, I don't mind, obviously. The QR to the website. If you have any questions, you can also ask them now. Are you going to give the whole course? Well, that's the thing. I'm not going to give this whole course. We have a better teacher to do that, that really specialized in methodology. To give you an ID, I score an average of 9.3. Julia is our methodology teacher. She scores a 9.6. She's incredible. She's really specialized in methodology. So we always choose her to do it because she's just simply better at that. She would usually also give this free core training, but she had some private issues. That's why I stepped in. And we have 3 for social psychology, 9.3, and Nicole for personality psychology. Julia indeed is Julia from the group chat. Yes. And the discount should be working on everything. Yeah. Okay. If you have any questions, and then we're gonna see if we have some more exam questions. Yes, indeed. And like I said, if you can't make those times, you can either choose to go for the full recordings. You can still ask Julia all the questions. You can also ask me questions. It's perfectly fine. You can also choose to, well, if you want to do it live but can't attend one session, that's not a problem. You can just send Esra a text, the girl in the group chat, and she's going to help you out with that. It's all perfectly fine. And in the full course, we're going to be discussing everything, obviously, not just this part. Okay. Okay. A little bit more theory, because the last 2 years, this used to come in the exam a lot, and then the last 2 years suddenly not. And that could mean either they removed it from the exam, or it could mean, and that's what you see quite often, that it rotates, so that the chance is actually bigger that it gets examined now. So I'm going to show you this, and then an exam question, how you can expect it, and then we are done for today. Okay. A confound check. Let's say I want to test the effect of caffeine on concentration, on focus. That's my research question. Caffeine on concentration. And let's now say, how do I measure this? I do this by giving coffee, and let's say giving nothing. And then I measure, well, let's call it focus, otherwise it's difficult. Focus, focus. And now I see that people that drink coffee, they score a 9. And people that drink nothing, they score a 1. And I conclude caffeine helps with focusing. Can you throw in the group chat what is a problem with this conclusion? What is a problem with this potentially? You can just free associate, throw it in the group chat. What do you think could be a problem? And then we're gonna discuss the solution after that. What do you guys think? I see some private responses, indeed. A problem with this is, well, nice that I score a 9 after drinking coffee, but how do I know if this is really because of caffeine? This could be because placebo, because you believe you concentrate better if you drink caffeine. Or it could be because of the sugar in coffee, or because of the warmth of the drink, or the fluid, or anything. So that's a problem. There is a confound, a potential alternative explanation for my effect. In your exam, they're going to give you a story, and you have to be able to tell which of these 3 methods I'm using. So I will walk you through it. Subtract it out. Subtract it out, remember it, SS, stable. This says, okay, you have to keep both conditions exactly stable, except for caffeine. So they say, what do? You give coffee in one condition and caffeine-free coffee in the other, decaf. Same brand of coffee, same amount of sugar, same heat. Everything should be stable except for caffeine. Because if I then see that you score indeed higher with caffeine, okay, that tells me a little bit better that maybe caffeine is indeed the thing that helps. Subtract it out. Keep everything stable. SS. Take it out says, well, if you're interested in caffeine, why would you measure coffee at all? Why don't you just take it out? Why don't you just take caffeine out of coffee? And in one condition, you give the caffeine pill, and then the other one, you give a placebo pill. Because then you know for sure that you're only measuring caffeine. So take it out says the thing you want to measure, caffeine, take it out and only measure that. Take it out. The third one, and I have a question for you about this one. Check it out. Check it out is a bit weird because what I do, in one condition, I give decaf coffee, so coffee without caffeine, and in the other condition, I give nothing at all. Why would I do this? Can you reason that? Can you think in the chat? Throw it in the chat. The more active you think, the better for your learning process. Why would I do this? Because I'm interested in caffeine, right? So why would I only measure decaf? What is the effect of this? Why would I do this? For God's sake. I see some answers. Indeed, placebo, for example. But not just placebo. I want to see decaf coffee, comparison to nothing. If I see that decaf on my focus thing gives a 9 and nothing gives a 1, for example, then I know, okay, that's interesting. Because then it must be that decaf coffee already increases focus a lot. Maybe because of placebo, maybe because of a warm drink, maybe because of the fluid, maybe because of the sugar. This is to check out all potential confounds. So this you could add to your research to really see, also create a condition like this and see what is the effect of my confounds. Placebo, warm drink, etc., etc. And in your exam, I'm going to show you a question in a bit, and then we're done for today. Check it out is quite often quite easy to see because it's a little bit weird. Subtract it out is about keeping it stable, and take it out about taking the thing out that you want to measure. Okay. I immediately give you the question and then we are done for today. If you are done, you say yes in the chat and then I'm gonna answer this. So if you get this on your exam, this is the way how they examine it. And like I said, also when they asked this on the exam, it used to be very popular, and then they didn't discuss it a lot in the lectures. And a lot of people made mistakes because they don't really discuss it a lot, and then you screw up. So I just want to make sure that if they suddenly introduce it again, that you at least have had it covered one time properly. So that's why I added it as a bonus, and because you worked along with saying yes, no, we actually got time to do this, so that's good. I see one yes, we'll give you some more time. Always check with these kind of questions. What do they want to find out? And then how do they do this? Okay. See one yes, so we'll wait for a few more and then we will discuss it. Perfectly done. Right on time, and if you have any questions, you can still ask me, obviously. If I should go over something again, that's also perfectly fine. Okay. See yeses. Okay, so how do I do this? I want to test the effect of alcohol responsiveness. That's also always important. What do they want to test? Alcohol responsiveness. Well, hooray, hooray. How do I do this? Okay, I give you a glass of beer. And to reduce the chance of confounds, I choose to give exactly the same and then alcohol-free beer. So let's say alcohol beer and no alcohol beer. And then I check how do you score. Okay, this is a good indication because I choose to keep both conditions exactly the same. So I try to stabilize as many factors as possible. I give you the same brand of beer, the same temperature, the same amount of gas in your beer, of wheat, of everything that's in beer, everything stable. And then sometimes they try to screw you over by giving a term like stabilize it out, but that is not a term. That is just to confuse you and to distinct who the people who actually paid attention or read this in the book and the people who didn't. So that's wrong. If I'm talking about keeping everything stable, stable, subtract, SS. So the answer here is answer B. What would it look like if it would be take it out? Well, then they would say, I want to test the effect of alcohol. I do this by giving you a glass of beer. But actually, what I do instead, I take out the alcohol of beer and I give one group pure alcohol and the other group placebo alcohol. Take it out. So, not screwing around with beer, just like the example I just gave, not with coffee, but taking out the exact thing you want to measure. That's why you always have to check what is the goal, alcohol. Check it out would be I give one group alcohol-free beer and the other group nothing, and then I'm going to see if alcohol-free beer in itself already influences it. And then I can see are there any strong confounds, placebo, liquid, gas, etc. Is this clear for everybody? Can I see yes or no in the chat? Otherwise, I will discuss it again. And if not, then we are done for today. And then we have covered quite a lot. So that's really nice. So I'm very happy with that. That's just gonna save you a lot of struggles, hopefully. And if you have any questions in the meantime, be it about this course, be it about exam training in general, about your study in general, can also be about going on exchange, on following an honors program, whatever. I know it's difficult to sometimes navigate through Tilburg University websites. So just let me know, send me a text, and I can always help. Okay, that goes for your entire bachelor. If there's anything I can do with anything, let me know. Okay. Also, just I am Dutch, so I can also just give you general advice on the Netherlands in itself. Buy an umbrella. That would be my general advice. I see a question. What is the difference between take it out and subtract it out? Subtract it out means you keep everything stable except the thing you're measuring. So alcohol-free beer and beer. And the rest everything else should be stable. Same brand, same temperature, same gas. That's subtracted out. And take it out says, okay, why would you measure beer at all? If you want to know alcohol, just take alcohol out. And one group you give pure alcohol, and the other group you give fake alcohol. So then you take out the thing you want to measure. And with subtracted out, you keep everything stable. Okay? Perfect. You're more than welcome. And very good luck with studying. Quite a few of you I will see at the exam training, obviously. Well, I won't see you, Julia. I will see you, but I've seen that you recognize some of your names. I saw you in the system. And for the rest, good luck with life. Yeah, don't die and such. Okay. Thank you. Have a good one. Cheers. See ya.